Good evening, ladies and gentlemen. Welcome to the Hong Kong Convention and Exhibition Centre, and thank you for attending the Shaw Prize Award Presentation Ceremony 2017. I am Dudu Shen, your presenter for tonight.
Good evening. I'm Leon Ko. I feel much honored to be the master of ceremonies again for the presentation of this distinguished international award, witnessing the outstanding achievements of the laureates with top-notch scientists and scholars from various parts of the world.
The Shaw Prize is an international award established under the auspices of Mr. Run Shaw. The prize is dedicated to honor individuals, regardless of race, nationality, gender, and religious belief, who have recently achieved significant breakthroughs in academic and scientific research or applications, and whose work has resulted in a positive and profound impact on mankind.
The Shaw Prize consists of three categories, namely the Shaw Prize in Astronomy, the Shaw Prize in Life Science and Medicine, as well as the Shaw Prize in Mathematical Sciences. Each year, the selection committees and the board of adjudicators ensure that the highest standard of the selection and adjudication process laid down by the Shaw Prize is kept.
Nomination and judging commenced in September last year. The results of the Shaw Prize 2017 were announced at the press conference held on 23rd day of May last. There are 5 Shaw laureates this year, and tonight they are here to receive the honor. It is time for the commencement of the Shaw Prize Award Presentation Ceremony 2017. Ladies and gentlemen, please rise to welcome our officiating guest, the Honourable Mrs. Carrie Lam Chan Yut Ngo, Chief Executive of the Hong Kong Special Administrative Region of the People's Republic of China. The Chief Executive, please.
We now invite the Shaw Laureates to enter the presentation hall. First, please welcome the Shaw Laureate in Astronomy 2017, Professor Simon D.M. White, please.
We now welcome the Shaw Laureates in Life Science and Medicine 2017. This year we have 2 Shaw Laureates. Professor Ian R. Gibbons, regrettably, is not able to join us tonight. Let us invite also the Shaw Laureate in Life Science and Medicine 2017, Professor Ronald D. Vail, please.
Last but not least, let us welcome the Shaw Laureates in Mathematical Sciences 2017. We also have 2 Shaw Laureates this year. Firstly, Professor János Kollár, please. And then, Professor Claire Voisin, please. We will now invite the chairman of the Board of Adjudicators, as well as the selection committees individually to deliver a speech. Firstly, may we invite the chairman of the Board of Adjudicators, Professor Yut Wai Kan, to deliver a speech.
Professor Kan is currently the Louis K. Diamond Professor of Hematology at the University of California, San Francisco. He is also the Shaw Laureate in Life Science and Medicine 2004. Professor Kan, please.
The Honourable Mrs. Carrie Lam and honoured guests. Since the first Shaw Prizes were awarded in 2004, many Shaw Laureates have gone on to gain recognition by other prestigious international prizes, including the Nobel Prize. Therefore, it gives me great pleasure to introduce to you the 2017 Shaw Laureates. The prize in astronomy is awarded to Professor Simon White of the Max Planck Institute for Astrophysics for his contribution to the understanding of structure formation in the universe. With powerful numerical simulations, he has shown how small density fluctuation in the early universe developed into galaxies and other nonlinear structures. The prize in life science medicine is awarded to Professor Ian Gibbons of the University of California, Berkeley, and Professor Ronald Vail of the University of California, San Francisco, for the discovery of microtubule-associated motor proteins. These are engines that power cellular and intracellular movement essential to the growth, division, and survival of human cells. The prize in mathematical sciences is awarded to Janos Kohler of Princeton University and Claire Voisin of Collège de France for their remarkable results in many central areas of algebraic geometry that has transformed the field and led to the solutions of long-standing problems that had once appeared to be out of reach. The Board of Educators are most grateful to the selection committee members for their recommendation. Thank you.
Thank you, Professor Ken, and please take your seat.
We now invite the chairman of the selection committee for the Shaw Prize in Astronomy, Professor Reinhard Genzel, to deliver a speech.
Professor Genzel is a director and scientific member at the Max Planck Institute for Extraterrestrial Physics in Garching, Germany. He's also the Shaw Laureate in Astronomy in 2008. Professor Genzel, please.
Dear Honorable Carrie Lam, dear Chair, and members of the board of the Shaw Prize Committee, ladies and gentlemen. We all, you as well as I, live in an expanding universe. More than 13 billion years ago, it was cooling down from a very dense hot state, which we call the Big Bang. Normal matter, like what we are made out of, what the Earth is made out of, sun, is actually a small fraction of the matter in the universe. The total mass in the universe is made by non-baryonic, as we say, dark matter. Even worse, to understand the observed geometry and expansion universe of our universe, there must be a pervasive, what we call dark energy, which controls the expansion of the universe currently. So the situation is very complicated. Our current standard cosmological models posits that small density and temperature fluctuations early on in the early universe, perhaps generated by quantum fluctuations at that time, were the seeds of the rich structure of we see today in our current universe. Galaxies with a wide range of sizes, masses, and appearance. Groups and gigantic clusters of galaxies and a vast cosmic web of intergalactic gas and galaxies connecting the largest clusters. But how can one prove this assertion? We cannot observe other universes in different stages of evolution to test the standard model which I've sketched out to you empirically. In principle, the evolution of cosmic structure follows the well-known laws of physics, of gravity, relativity, along with hydrodynamics and electromagnetism. In practice, solving these theoretical equations turns out to be extremely difficult. So over the past 4 decades, Simon White, together with an exceptional group of collaborators and students, has developed N-body computer simulations as a new tool of extraordinary power, yielding fundamental insights into cosmic structure formation. The most recent simulations capture with astounding detail the time evolution of cosmic structure between a few million years after the Big Bang to our current epoch, and match observations in some detail. White has investigated and illuminated almost every aspect of the current paradigm of nonlinear structure formation. As early as 1976, he conducted numerical experiments showing that strong subclustering was expected during gravitational collapse, plausibly explaining why there is this lumpiness in the distribution of galaxies. In 1978, White and Rees were the first to suggest that galaxies form by the collapse of dissipative normal matter, but in a sea of dark matter surrounding it. In the early 1980s, White, Davis, Estacio, and Frank showed that the dark matter could not consist of neutrinos or otherwise known similar particles. White and his collaborators argued that the dark matter was cold and may consist of a yet unidentified heavy particle. In '97, White, Frank, and Navarro showed from n-body simulations that the density profiles of the so-called dark matter halos, which I described to you as the building blocks, are described remarkably well by simple two-parameter mathematical formula now known universally as the NFW profile. In '98, White, Moe, and Mao made the first specific predictions of how disk galaxies like our own may have formed at the centers of such dark matter halos. It may still take decades or more to accurately simulate the universe in realistic detail. Nevertheless, we believe that this is the right time to recognize the remarkable advances in our theoretical understanding of cosmic structure formation. Simon White's work and leadership over several generations of increasingly realistic modeling stands out and makes him a most worthy recipient of the 2017 Shaw Prize in Astronomy.
Thank you, Professor Genzel, and please take your seat.
We now invite the chairman of the selection committee for the Shaw Prize in Life Science and Medicine, Professor Randy W. Sheckman, to deliver a speech.
Professor Sheckman is currently a professor in the Department of Molecular and Cell Biology of the University of California in Berkeley, USA, and investigator of the Howard Hughes Medical Institute. Professor Sheckman, please.
Honored awardees and distinguished guests this evening, animal and plant cells have an elaborate network of tracks for moving cargo similar to modern light and heavy rail systems in large cities. One of the two major tracks is formed by a protein called tubulin, which serves to guide the movement of particles within cells and to control the waving movement of cilia, finger-like projections that allow cells to sense their environment or to propel things along their surface, and in some cases to allow cells to swim. Tubulin tracks also organize the duplication and separation of daughter chromosomes and organelles such as the mitochondrion when cells divide, and guide membrane compartments down the axon in nerve cells. Ian Gibbons, who regrettably is unable to be with us this evening but is proudly represented by his daughter Wendy, and Ron Vail discovered the motors that engage tubulin cables in cells and to promote the movement of membranes and chromosomes. Gibbons' initial discovery, made in the 1960s, came from the observation of beating cilia, these finger-like projections on cells, isolated from a freshwater protozoan, from which he extracted a protein that he called dynein that had the ability to cause tubulin filaments to slide past one another in the presence of the cell's energy currency, ATP. When this work was first presented at a meeting of the American Society of Cell Biology, one notable cell biologist was heard to exclaim, "Oh my God," from the audience, and another recalled that Gibbons received a standing ovation at the end of his talk. The only person, the only one this person had ever heard given such a recognition for his lecture. In 1985, Vail, working as a young student in a summer program at the Marine Biological Laboratory in Woods Hole, Massachusetts, found an activity in the cytoplasm extruded from the giant axon of a squid that propelled membranes along tubules in a direction opposite to that sustained by dynein. Vail and colleagues dubbed the new motor kinesin, and we now know that these two ATP-driven machines, dynein and kinesin, which together are encoded by dozens of genes, are responsible for much of the dynamic movement of material within virtually all cells that have a nucleus. The processes that they propel are intimately involved in normal human growth and development, and diseases linked to these genes lead to chromosome aberrations, neuropathy, schizophrenia, neurodegeneration, kidney disease, and infertility. In spite of the medical importance of these motors, Vail and Gibbons, as passionate basic scientists, focus their energies on ever more precise visual and atomic resolution imaging of the motors as they carry their cargo along the surface of a tubule. Our two awardees, though professionally and personally connected, come from very different backgrounds and traditions. Gibbons did much of his work in collaboration with his late wife, Barbara, at the University of Hawaii. Vail is a native Californian and has spent his independent career on the faculty at UCSF and as an investigator of the Howard Hughes Medical Institute. But far from staying in place, like his motor protein, Vail maintains a dizzying pace of travel and engagement as a frequent teacher at courses in Woods Hole and in India, and as the lead in a far-reaching online curriculum for life science called iBiology, which brings scientists from around the world to San Francisco to produce open-access educational materials. Gibbons and Vail have been recognized with numerous national and international prizes and elections to honorific societies, but the Shaw Prize is, we believe, the first that has recognized the complementary and interdependent nature of their discoveries. We celebrate their achievement and the impact it has had on basic cell biology and the application of that knowledge to human health.
Thank you, Professor Sheckman, and kindly take your seat.
We now invite Professor Timothy Gowers, Chairman of the Selection Committee for the Shaw Prize in Mathematical Sciences, to address the audience. Professor Gowers, please.
Professor Gowers is currently a Royal Society Research Professor and holder of the Rouse Ball Chair in Mathematics at the Department of Pure Mathematics and Mathematical Statistics at the University of Cambridge, UK.
Good evening. The Shaw Prize is intended to recognize work that has had a major impact and that is still fresh and exciting. This year, the Selection Committee in Mathematical Sciences decided to reward some quite remarkable achievements in the field of mathematics known as algebraic geometry. As its name suggests, algebraic geometry is a kind of fusion of geometry and algebra, a fusion that began when Descartes introduced his famous Cartesian coordinates, in which points could be represented as pairs or triples of numbers, and geometrical concepts such as length and area could be converted into algebraic ones. In particular, shapes can often be represented as sets of solutions of equations. For example, a circle of radius 1 can be represented as the set of solutions to the equation x squared plus y squared equals 1, which may be familiar to you from school mathematics. Modern algebraic geometry has taken this basic idea and run with it. It turns out that many geometric concepts become easier to understand when they are treated algebraically, and also that many algebraic concepts become easier to understand when they are treated geometrically. This fusion of algebra and geometry, followed by an extraordinary process of abstraction involving concepts with exotic-sounding names such as varieties, sheaves, stacks, schemes, étals, and crystalline cohomology, which are mysterious not just to non-mathematicians, but also to many mathematicians who are not fortunate enough to be algebraic geometers, has led to major advances in algebraic geometry itself, and also in many other areas, from number theory to mathematical physics. The winners of this year's Shaw Prize in Mathematics are both towering figures in the field. János Kollár, who grew up in Budapest, but is now a professor in Princeton, has many achievements to his name. One of his major strengths is an ability to develop pioneering new theory and lay groundwork that becomes central to the work of many other mathematicians. In particular, he has made major contributions to a fundamental area of activity known as the minimal model program, which, roughly speaking, attempts to find, for each solution set of a system of polynomial equations, a simplest representation. This has seen big advances in the last few years that would have been inconceivable without Collard's work. He has also done very important work in the geometric classification of higher dimensional solution sets. It is not too much of an exaggeration to say that he has single-handedly built a new and extremely active subfield of algebraic geometry. As a child, Claire Voisin entertained thoughts of becoming a philosopher. Who knows what she might have achieved had she followed that path, but fortunately for mathematics, she didn't. Instead, she too became one of the world's foremost algebraic geometers. She solved a decades-old problem due to Kodaira, one of the giants of 20th century algebraic geometry. She found a new technique for proving that solution sets are not necessarily equivalent to ordinary n-dimensional space, a breakthrough that quickly led to many further results. And she found an example that demonstrated that what had seemed to be a promising approach to solving the Hodge conjecture, which is one of the problems for which the Clay Mathematics Institute offers $1 million reward, could not work, thereby shedding very important light on a very important problem. Between them, Collard and Voisin have transformed modern algebraic geometry, and their influence will continue to be felt for many years to come.
Thank you, Professor Gauss, and please take your seat.
The research findings of each of our Shaw laureates have undoubtedly made important and enormous contributions to mankind. The Shaw Prize is an international recognition and honor to them.
As a recognition and acknowledgement to the outstanding contributors of the Shaw laureates, each prize bears a monetary award of $1.2 million. Each Shaw laureate will also receive a certificate and gold medal. The Shaw Prize Award Presentation Ceremony 2017 will now begin.
Ladies and gentlemen, tonight we're much honored to have the Honorable Mrs. Carrie Lam Chang Yut Ngo, Chief Executive of the Hong Kong Special Administrative Region of the People's Republic of China, to officiate at the presentation ceremony. First, we will present the Shaw Prize in Astronomy. The award goes to Professor Simon White. Professor White, please.
Set up a calculation inside the computer, which was a spherical region in the uniform universe, which was expanding. And then as the calculation evolved, it became lumpier and lumpier, and all these lumps eventually fell back together to make a single cluster of galaxies.
We now invite the Shaw Laureate in Astronomy 2017, Professor Simon White, who is currently the director of the Max Planck Institute for Astrophysics, Germany, to deliver his acceptance speech. Professor White, please.
It's indeed a great honor for me to be here tonight. I'd like to begin by thanking the Shaw Prize Foundation, Lady Shaw herself, and the Astronomy Selection Committee for recognizing the key role that computer simulations have played in clarifying the origin and growth of structure in our universe and the nature of its primary constituents. I'd also like to thank Chief Executive Lam for being here this evening to make the presentations. Over the last 40 years, computer power and capacity have grown by a factor of about 1 billion, much faster than any other aspect of our science. I have been fortunate to be able to harness this dramatic growth to study the nature of dark matter and the formation of galaxies. Scientific research is very much a cooperative enterprise, and I wish to pay tribute to those who are here tonight. Sverre Aarseth was and is a true pioneer of numerical astrophysics. His star cluster code enabled my very first simulations of the formation of galaxy clusters and the merging of galaxies. Carlos Frank and I met in Cambridge when we were both young scientists. This began a lifelong quest to understand how our universe took form and what it is made of. We joined forces with Mark Davis and George Efstathiou to show that the structure Mark observed in his galaxy maps was inconsistent with dark matter being any known kind of matter, but could be explained by an entirely new kind of elementary particle, so-called cold dark matter. Julio Navarro's joint work with Carlos and me showed that dark matter halos should all have similar internal structure, a result now confirmed by many observations and the subject of my most highly cited papers. Two remarkable graduate students of the 1990s have also become long-term collaborators. My future wife, Guinevere Kaufmann, found new and creative ways to simulate the formation of the galaxy population as a whole, while Volker Springel designed and implemented new algorithms to treat a greatly expanded range of physical processes. Together, their efforts led to a new generation of simulations, the most famous being the Millennium Simulation. Over the years, simulations have helped establish a standard model for the formation of all cosmic structure that have become so realistic that non-specialists sometimes mistake them for real astronomical images. It has been a privilege and a pleasure to work with you all on this program. Thank you very much, and thank you very much again to the Shaw Prize Foundation.
Thank you, Professor White, and please take your seat on stage.
Now comes the Shaw Prize in Life Science and Medicine. The award is shared equally by two recipients. The first share goes to Professor Ian Gibbons. As Professor Gibbons is unable to join us tonight, may we invite his daughter, Miss Wendy Gibbons, to receive the prize on his behalf. Miss Gibbons, please.
It's the nature of the proteins in these wonderful structures. I had it in a test tube. I'd go ahead and look at it, and it wasn't completely pure. When we got it pure enough, we gave it the name of diamine.
Congratulations, Professor Gibbons, and thank you, Ms. Gibbons.
The other recipient of the Shaw Prize in Life Science and Medicine 2017 is Professor Ronald Vail.
This kinesin story developed, I would say, halfway through my training. These generate all the motion that is associated with life inside of you.
Firstly, we would invite Ms. Wendy Gibbons to share with us the acceptance speech of Professor Ian Gibbons. Professor Gibbons is currently the visiting researcher in the Department of Molecular and Cell Biology at the University of California in Berkeley, USA. Ms. Gibbons, please.
Chief Executive, Lady Shah, and distinguished guests, I am honored to be here to accept the award of the Shaw Prize on behalf of my father, Ian Gibbons, as he is too ill to travel to Hong Kong at the current time. We wish to thank the Shaw Foundation and the prize committee for their generous acknowledgement of my father's life's work, which consisted of probing the basic scientific question of how biological cells carry out motion. As the story of dynein and other molecular motors continues to unfold, we have begun to learn how it is that cells transform chemical energy into the mechanical energy necessary for growth, transport, and motility. The study of these three vital life functions at the cellular level clearly holds much future promise for a better understanding of fundamental processes in biology, as well as solutions for many challenging health problems. As any researcher knows, uncovering nature's intricacies takes an uncommon blend of meticulous teamwork as well as individual creativity and determination. In this spirit, my father wishes me to recognize George Wald at Harvard University for Wald's encouragement of the entrepreneurial attitude that allowed my father to initially discover dining's ATPase activity. He also acknowledges Bob Kane for his smooth directorship of the Koalo Marine Laboratory in Hawaii and the state of Hawaii for its financial backing of his research, as well as Beth Burnside and the University of California at Berkeley for providing him with a scientific home in California to continue his research after he retired in Hawaii. Throughout his career, the U.S. National Institutes of Health provided critical grants supporting my father's work. His gratitude extends also to the many students, associates, and collaborators on the study of cell motility, as well as all of the administrators and staff who supported his efforts over the years. Most especially of all, my father wishes to acknowledge his late wife, the protein chemist, Barbara Gibbons, my mother, for her skill in helping him stay organized and focused, as well as for keeping the sea urchins healthy and alive, and the lab humming along productively. Thank you once again.
Thank you, Ms. Gibbons, and please return to your seat.
We now invite also the Shawl Laureate in Life Science and Medicine 2017, Professor Ronald Vail, who is currently the professor of the Cellular and Molecular Pharmacology Department at the University of California, San Francisco, USA, as well as an investigator of the Howard Hughes Medical Institute, to deliver his acceptance speech. Professor Vail, please.
I'm very thankful and deeply honored to receive this year's Shaw Prize in the Life Sciences and Medicine. And it's also a wonderful pleasure for me to share this prize with Dr. Ian Gibbons, who's a close colleague and friend. And I'm also thankful to be able to share this wonderful evening with my wife, Karen Dell, and my longtime friends, Cindy Becker and Jeff Epstein. Ian discovered dynein, a molecular motor protein, when he was 30 years old, and I discovered kinesin when I was 25. We then spent our careers trying to understand how these amazing biological machines work, and eventually that research was recognized by the Shaw Prize Committee. But my point is that older scientists often are the ones receiving the prizes, but the leading edge of science is really being driven by young people. And I want to recognize and honor the young graduate students and postdocs in my lab, both past and present, who very much contributed to this year's Shaw Prize. And I salute them here. These young scientists are my heroes, and they are the backbone of the scientific enterprise. I also want to thank the non-scientists that are here today and elsewhere who support basic research. Run Shaw and Mrs. Mona Shaw understand the value of education and science. Interestingly, my parents also were in the film and entertainment industry, and they too, like Mr. and Mrs. Shaw, valued science. To face the great challenges in society in the coming decades, we need to build a strong partnership between the general public and the scientific community. And we scientists need to make a stronger effort to explain our work and also to forge a broader appreciation of the sciences. Film and video, which Run Shaw pioneered in Asia, can be a great vehicle for communicating science to the public. I founded a video-based lecture series called iBiology, and next year we're going to release a major documentary on genome editing for the general public. And it is my hope that scientists, filmmakers, artists, politicians can all work together to convey the wonder of science and the importance of science to our society. And in closing, I want to thank the Shaw Foundation for the amazing work that they are doing to support science and also conveying science to the public on occasions like this. Thank you very much.
Lastly, we will present the Shaw Prize in Mathematical Sciences 2017. This year, the award is shared equally by two recipients. The first share goes to Professor Janos Kolar.
We try to understand geometry using algebra and try to understand algebra using geometry. I'm especially interested in the cases where the shape is very sensitive to small changes of the numbers.
The other recipient of the Shaw Prize in Mathematical Sciences 2017 is Professor Claire Voisin.
Claire Voisin, I am a mathematician. I like in math everything that I don't like in life. Then I discovered algebraic geometry, which has an extremely beautiful theoretical body.
We would invite Professor Janos Kolar, who is currently a professor in the Department of Mathematics at the Princeton University, USA, to deliver his acceptance speech. Professor Kolar, please.
The Honorable Chief Executive, Mrs. Shah, ladies and gentlemen, I am deeply humbled and grateful to the Shaw Prize Foundation for this award, and I hope to live up to the example of generosity and vision shown by the late Mr. Ronald Shah and Mrs. Mona Shah. I would not be here without the help, guidance, and work of many people who made me the person I am. I thank foremost my parents who brought us up under difficult circumstances, my wife Jennifer, who always stood by me, my high school mathematics teacher named János Pogány, who installed in us the love of learning, my thesis advisor, Teruhisa Matsusaka, who taught me to look further ahead, and my many colleagues and students who influenced me in numerous ways. Mr. Shah received many honors in his life, and he worked tirelessly and generously. And so I accept this award in the same spirit as a call that I should work harder in the future as a mathematician, an educator, and a person. Thank you.
Thank you, Professor Kolar, and please take your seat on stage.
Last but not least, we now invite also the Shaw Laureate in Mathematical Sciences 2017, Professor Claire Voisin, who is currently the professor and chair in Algebraic Geometry at the Collège de France in France, to deliver her acceptance speech. Professor Voisin, please.
The Honorable Chief Executive, Mrs. Mona Shaw and the Shaw Prize Foundation, the Board of Adjudicators, the members of the selection committees, ladies and gentlemen, thank you for giving me the opportunity to say a few words. There are many people whom I would like to thank today. First of all, I would like to thank the Shaw Foundation for its generous support to research. Devoting oneself to science is the greatest opportunity one may have in life. And I do not have strong enough words to express how important the support, which might be either practical or political, to science is. On my personal side, receiving the Shaw Prize is a great honor and a wonderful recognition of my research. I also thank the members of the Shaw Prize Committee for Mathematical Science for selecting me as a recipient of the Shaw Prize. The list of previous awardees in the field of mathematics is very intimidating. It is a great pleasure for me to share the prize with my friend and colleague, János Kollár, whom I have known for 30 years and whose contribution to algebraic geometry is of major importance. This 30th anniversary is not invented. It corresponds exactly to my stay as a postdoc of Herb Clements in Salt Lake City, where I first met János. This stay has been important for me, influencing the direction of my research and reinforcing the influence of the American School of Algebraic Geometry, in particular Griffith's ideas on Hodge theory, that is, on the theory of Hodge structures, on my work. I would like to acknowledge also the influence of Arnaud Beauville, my thesis advisor, who introduced me a long time ago to algebraic geometry, which is a fantastic mix of beautiful theories and fascinating problems. On a personal touch, I cannot emphasize too much my debt to my family, and in particular my husband, Jean-Michel Coron, for their constant support, but also for teaching me enjoying life. Finally, I am also greatly indebted to the CNRS, the National Center for Scientific Research in France, which has employed me for 30 years as a full-time researcher. Thank you.
Congratulations and thank you all laureates. We now invite our officiating guest, the Honorable Mrs. Carrie Lam and Professor Vazan, to stay on stage for a group photo. Scientific research has embedded boundless possibilities. We look forward to seeing you again next year and to witness more accomplishments of distinguished scientists and scholars. Goodbye and see you next year.
Thank you. Goodbye.